Reusable Testbench. Now, I would like to show you how we create reusable test benches in SystemVerilog and how they are different from the usual test benches that we create in HDLs. Look at this example. Treadmill. It's a configurable machine. Whoever wants to use this machine, basically the person has to make all the settings. The settings could be how long he wants to run, how fast he wants to run, or how many calories he wants to burn. So what I would say, overall, the settings would be based on his fitness goals. Let's look at different scenarios. He wants to run at 8 km per hour. He doesn't want to burn too many calories because he might be into bodybuilding. Look at this scenario. In this case, she wants to run at 6 km per hour. She might be new to fitness club. First time she might be using treadmill. So she wants to walk on the machine and feel how the machine works. She doesn't want to think of how many calories she can burn or how fast she can run. She wants to walk on the machine and feel how the machine works. The objective is entirely different. Now look at this scenario. He wants to run at 12 km per hour. He wants to run for more than 60 minutes because he has been participating in various marathons, and his focus would be building strength. This is how different people will be using same machine for different objectives. You go to any fitness club, you might not find hundreds of machines there. There could be 5 or 10 treadmills, but there could be hundreds of customers. Everyone will be using almost the same machine. And how it works? For example, you want to use the treadmill, then you get on the machine, you put on the power, you make all the settings. So while making the settings, you need to think how fast you want to run, how long you want to run, and how many calories you want to burn. You make all the settings, use the machine, and then get off the machine. The next person goes. The person will reset the machine. And once again, the person will make the settings, and then the person will use the machine. That's how everyone is going to use the machine. So basically, the machine is configurable. Look at this. The machine has control panel, and we make all the settings through control panel. That's how basically we configure the machine and use the machine. That's how we want to build reusable test bench. The test bench will be like machine. It's going to do certain things repeatedly. In this case, the treadmill, maximum what it does, it rotates the belt. So you can adjust the speed. You can even adjust the slope also. That's how basically we configure the machine. The same way we would be able to configure the test bench also. The test bench is like machine. It's going to do certain things repeatedly. Look at this. This is verification environment or test bench infrastructure. This is what we discussed during verification process. Usually the experienced verification engineers, they create this environment based on the test bench architecture. This environment does certain things repeatedly. It generates packets, it drives the packets to the DUV, and it collects the output packets from the DUV. It compares the output packet with expected packet. It generates packets, it drives packets, it collects the packet, it compares the output packet with expected packet. This is what it's going to do repeatedly, like the way the treadmill rotates the belt. But it's also similar to configurable machine. So it's called configurable test bench. These experienced verification engineers, they create this environment with different kinds of configuration parameters. So different test case writers will be using the same environment for generating different kinds of scenarios. Look at this particular example. The test case writers might want to try different things. Someone might say, I want to generate small packet. The other person might say, I want to generate big packet. And someone else might say, I want to generate corrupt packet. So the packets could be different. That's how the parameters, configuration parameters would be. So each test case writer will generate different kinds of packets. In general, if you look at the configuration would be something like this. How many packets and what kind of packets? How many packets and what kind of packets? So the scenarios could be 100 small packets, 10 big packets, 1 corrupt packet, or the scenario could be 10 small packets, then immediately 5 big packets, and then immediately 1 corrupt packet. This is how different test case writers will be generating different kinds of test scenarios. Look at here. On top of this verification environment, different test case writers will be writing different test cases. This is how the data flow is going to happen. The test case will define what kind of packet has to be generated and how many packets have to be generated. So based on the configuration, the environment is going to generate the packet. The packet will be driven to DUV. So the packet will be converted into binary because DUV can understand only binary. And then the binary values will be driven to DUV. When the DUV produces binary values, all the binary values will be collected by the verification environment and the values will be converted back into packet, and eventually the packets will be compared. If the comparison is going to be successful, then the coverage values will be generated. This is how the data flow happens. This is how we create a reusable verification environment, and this is how we generate different kinds of test scenarios to verify the DUV.